Good evening, all. Today, we will be solving some very interesting questions from the computer networks. These are numerical conceptual programs that help us understanding the data transformations, multiplexing, and bandwidth requirements. So, we start how the problems are solving, how can you do all these problems in this thing. So now, initially, we start the first program. The first question or first problem, what is that means? This is the some raw 4K screen data rating. Why it is taking for it? It's discussing about some framings. So multiplexings. So now, count the plexes from the frame. For like screen, 3480 into 2160 pixels. So multiplying with the 24 bits to get the bits per frame. Then into 60 frames per second. So finally, we get the answer is 11.94 megabits per second. Why it is do like this? All the instructions given by this, so we can calculate the data rate is needed. So how much data will be required to do that? So that is the thing of the happening in this first question. So now we go to discuss about second question. The second question is talking about the some channel or some TV channel. Will example take that some TV channel with four leveling. It means four leveling of noiseless signals will be taking. So how can you calculate this? By this problem, we're using the Tversky's theorem. Okay. So by this theorem, we have the formula with a constant value R is equals to 2b log to m. Okay. Here all the values are given by in the question. The television channels means B means channels. The television channels means B is equals to 6 megapages and M is equals to 4 bytes because of we taking the 4 channels. Here it is 4 level of things are happening. So now we can into and we can calculate all the symbol when we get the answer that is 24 megabytes per second. Okay. Next we take the another question is the completely depends upon digital signals. The digital signals always calculate the maximum rate because of they require that. In the question they ask about maximum HUL data rate. So in this we can use this Evans capacity formula. This formula when constant formula is C is equals to V log 2 into 1 plus SNR. In this problem, why I take this is here everything is in the program. This what is that means the values are given that this E is equals to how can calculate this 3 kilohertz channels will be required. By the signals is noise, then the ratio is 20 megabits. So what is the maximum thing? So we can substitute all the values in that formula. Then we can then we get the answer that is 20 kilohertz. So next we take the fourth question. The fourth question is all about signals, talking about signals. The signals are all depending upon everything frequency digital multiplexing. Why we are taking this multiplexing is here mentioned that here it's mentioned what is that means 10 signals each requiring 4000 hertz is multiplied on a one single channel using FBM. So FBM means here frequency division multiplexing. So finally you can calculate the minimum bandwidth required the multiplexer channel. So what is that? So here we know everything. What is the playground here? 10 into 4000 is equals to 40 kHz. So what is the bandwidth? Grand bandwidth means distance between one bit and another band. The distance between one band to another means that is the grand width. The grand width distance is 9 into 400 because it's given all that because of here given that assume the grand width is 4000 hertz. So it's taken that. And why we are calculating 9 here is here to already take it to 10. The minimum level is the next single one thing. So that's why minus 10 minus 1 is coming to 9. So here 9 into 400 is equals to 3600. So and then total. How can you total means the bandwidth all he asking about total. So how can you total that bandwidth and the between gap bandwidth space will be taken. So that's why this payload bandwidth plus grand bands. So 4000 plus 3000. So finally 2.3 gigahertz. So now we can take another. The PCM sampling time being at 25 milliseconds. So how it is taken? So the voice bandwidth is 0 0.4, 0 0.4, 0 to 4. It means voice is 0 0.4 and so the voice bandwidth is 0 0.4, 0 to 4, and we know that and video bandwidth is 0.5, 0 to 5 kHz. That the difference between is so important because of if they're asking voice 0 to 4, it's maximum take we can take the maximum level, so 4 will be considered. And they are asking about their video or audio anything, then we can take the 0 to 5 kHz, but we have to take the maximum level, so 5 Hz will take it. So here they're asking only for voice, so that's why you consider the 0 to 4 kHz band. This is and the rate is 8 kilohertz. So sampling period is here the sampling period is 1 by 8,000 because of the constant thing. Then it has come to a 125 kilohertz. So finally the answer is 125 between the samples, between the two samples with the coming of that is 225. So next we go to sixth question. The sixth question is completely depend upon signal to voice radio. Signals to voice radio. I'm already told you that. So voice is 0 to 4 and audio is 0 to 5. So here we can consider that formula is the constant formula that is log 2. Just wait a second. Log 2, this is the constant formula you all discussed in previous questions. Log 2 plus SNN. This problem is mainly depends upon that how they carry the how much carry the things that happened in that. So that's why this problem is being, and what the values are given in that we can substitute immediately and you can do solving the problem. So then we get it at 2.8. So next problem, cable. So why you are cabling this problem means each and every site, each and everything are happen for the frequencies in this thing because of TV signals on the radios, all they happen for using the frequency division medium. So that's why you can using the frequency division medium. Why it is mainly used means it's always separates, it's always sorting the frequencies continuously and give the certain time to period how to do that. So that's why we can use the. It means each and every channel occupies this separate frequency slot continuously. Then always sorting and always separating that all they combine to each other. Then we give the good output. So that's why we can use the frequency division multiplexing here. So last question, the cable company using something. So question is there, so you can read properly because of all this terminologies and all this coming in it. So here why you are discussing about this topic means is multiplexing all this is a physical media is there. Is media is there in that media we can discuss physical media. Then physical media we have to do them with guided and unguided medias. So here we're completely discussing about guided media. It is a wire. It's a wide media. So why you are using here is why are you is this each and segment can be guided at this 100 to 100 meters. It's okay. And that is divided into 50 homes. 150 homes, 50 homes will divide on that. Then we can immediately all the capacities of channels will be divided into splitting together. Then everything cables are everything is connected together. Then it's give the some splitting something. So they give something or something network connection. So that's the splitting and the combining together. Then we give the proper solution for that. So all the things that happen for this thing here. So yeah. So all this happen in this. So and that's it. We are solve 8 computer network programs step by step. I will detail. So these concepts like FPM, PDM, physical media, multiplexing, all these topics are cleared in these programs. And all these theorems, all these things are is backbone to digital communications and internet also. So I hope you understand If you have any doubts, just comment me. I will explain in detail in another video and next videos. So thank you. Thank you. Bye. Thank you all.